How was our universe born? And if this seems hard to answer, then how about this? What was before our universe? Okay, I will explain how it happened. Before starting the video, just subscribe to my YouTube channel, Aerotech Afros the Programmer, and like this video and comment whatever doubts you have related to space. So let's start the video. While scientists are looking for the answer to the most difficult question in history, let's find out what they've come up with so far. In the 20th century, we've shed light on this mystery, all thanks to this man, Edwin Hubble. One day on Mount Wilson in Southern California, he aimed his telescope at the sky and found out that these random clouds of gas flying everywhere are actually other galaxies, and there are a lot of them. He also learned something else, something that changed the world forever. They're moving. So what, you may ask? Well, it meant one very important thing. The universe is expanding. And if it's expanding, then it probably had a beginning somewhere. Right now, all we have to do is run time backwards and see where the beginning was. The Big Bang. It took scientists many more years to come up with a full-fledged theory, the Big Bang theory. And here it is. Nothing has ever been anywhere because neither when nor where existed. Do you get it? Actually, no. There was one thing. It was the so-called cosmic singularity, a state of our universe in which it was incredibly small, dense, and very hot. Imagine if our universe was compressed into a small ball. The pressure and temperature inside would be enormous. At some point, it became impossible to withstand them, and here comes the Big Bang. It was an outburst of energy and matter that created everything we see now, time and space, basic physical forces. It also scattered quarks everywhere. These quarks, tiny particles that make up our world, were all boiling in an incredibly hot cosmic broth. When it cooled down, gravity began to attract them to each other. They gathered into atoms, then molecules, and then into the first objects, stars. All this happened just some 12 to 14 billion years ago. Guth's discovery. All right, now we know how our universe was created, but what was before that? Alan Harvey Guth, an American theoretical physicist and cosmologist, has devoted his whole life to solving this mystery. After learning about the Big Bang theory, Guth found some flaws in it. For example, the distribution of matter was very even, although it shouldn't have been. Let's hang a balloon filled with paint from the ceiling and lay a white canvas on the floor. If we drop the balloon, it will burst, and we'll see absolute chaos on the canvas. A bunch of spots scattered everywhere randomly, none like the other. But that's not really what the universe looked like. Instead of throwing a colored ball from the ceiling, let's draw a small red dot on the canvas. Now, let's expand it a little more and more, capturing this all on frame-by-frame shooting. We'll see a circle gradually growing in all directions. That's the reality. The early universe was very even and proportional. That was Guth's discovery, the theory of inflation. Here's what it says. Even before the Big Bang, there was some kind of force that could give the bang a strong acceleration. Something that was able to distribute everything in space instantly and evenly. Guth's theory was a success, and now most scientists rely on it. For most of them, this idea of the birth of the universe is quite enough, but not for all. Martin Bojewald is a German professor of physics, and in his opinion, the universe was born quite differently. Remember when we talked about cosmic singularity, the state of the universe in which it was small, infinitely dense, and super hot? According to Martin's theory, the singularity couldn't just appear out of nowhere. This is nonsense. But then where did it come from? Quantum time. Let's look at a pendulum on an old clock. The pendulum rotates back and forth. Its movement is smooth, continuous, and non-stop. This is how we usually see time. It flows and never stops. But quantum time, quantum time doesn't work that way. It's more like the second hand of a clock. It consists of small segments and makes short pauses. And just like with the second hand of a clock, the beginning of one segment of time is always the end of another. See what I'm getting at? Let's go back to balloons again. According to the Big Bang theory, once upon a time, our universe began to expand, inflate like a balloon. But sooner or later, it will blow away. The universe will start shrinking and return to the state of cosmic singularity. And then, guess what? The Big Bang too. Nothing appears out of nowhere and disappears into nowhere. According to Bojewald's theory, the beginning of each universe is the end of the previous one. Our universe is not at all the first and not the last. Millions of similar universes existed before us and will exist after us. This theory, although it sounds very logical, is far from complete. Unfortunately, we don't have enough knowledge to find all the evidence for it. So for now, all this is just a hypothesis. Parallel universes. But some people come up with even stranger ideas. Scientists promote such unusual theories that no one could even think of. Neil Turok, a South African physicist, and his colleague Paul Steinhardt, an American theoretical physicist, look for answers far beyond our universe. They say that, yes, our universe isn't the first one. There have been and will be an infinite number of them. And not only will there be endless Big Bangs, but our universe is just one of an infinite number of others. And all of us are stuck in a cycle of endless rebirths of parallel worlds. This sounds incredible and frightening at the same time. But how does it work? According to this theory, our universe is located inside a so-called brain, as in membrane. In other words, we're stuck in some kind of elastic surface that's capable of contracting, stretching, oscillating, and so on, like pieces of fabric on a rope. These parallel universes are located near each other. Each one has a neighbor. We're not the exception. Another universe may be an inch from ours, but we can't see it. That's because there's a tiny space between us and this brain collision. This tiny space contains the fourth dimension. How do these universes originate? Through brain collision. These brains are getting closer to each other very, very slowly until one day they finally collide. Their collision creates two Big Bangs and two parallel universes. Then they're moving away from each other. The created worlds continue to live. We're currently at this stage, but when they disappear, the brains collide again, and this will lead to the birth of a new universe. Remember the inflation theory? There was a mysterious energy that pushed and accelerated the Big Bang. Well, if we did collide with another universe, that would explain everything. Of course, everything described here is a great simplification. When you hear that our world is some piece of fabric on a rope, it sounds like complete nonsense. But this idea is based on string theory and M theory, two giants of quantum mechanics. If they turn out to be true, they could explain almost everything in our universe. Creating a theory is an incredibly huge process. Turok and Steinhardt made a huge amount of calculations and swept away many, many non-working theories. Also, to work this out, they have to overcome the limits of the human mind and think in 11 dimensions at once. Unfortunately, this crazy and elegant idea was laughed at. Turok and Steinhardt say that scientists are regular people, just like everyone else. They're also afraid of change and the unknown. And it's really scary to question everything we once believed in. Many years ago, people didn't believe that the Earth was round. Then they were outraged by the Big Bang Theory. We can't make discoveries without struggle and fear. That's why Turok and Steinhardt don't plan to give up so easily. After all, the evidence that we have now only says that each of the three theories is equally possible. So which answer is correct? At least, not at this stage of human development. Unfortunately, as long as we have no evidence, we can only theorize. But maybe one day we'll find something that will open our eyes once and for all. Maybe one day we'll solve the mystery of how our universe came to be. Now, I think you have understood how the universe was made. Okay, next, we will go to the topic of how the Milky Way galaxy was made. So, before going to the topic, just subscribe to my YouTube channel, Aerotech Afros the Programmer, and please like the video. Formation of the Milky Way galaxy, a journey through cosmic history. Cosmic beginnings, early universe and structure formation. Around 13.8 billion years ago, the universe burst into existence with the Big Bang. At this moment, it was a dense mix of particles, radiation, and tiny variations called quantum fluctuations. These variations laid the groundwork for the formation of galaxies through the pull of gravity. Dark matter and halo formation. Enter dark matter, an invisible substance that doesn't emit light or interact with normal matter but exerts gravitational force. It gathered in halos around denser regions, acting like scaffolding for the accumulation of gas and dust, the building blocks of galaxies. Protogalactic clouds and early galaxy formation. Within these dark matter halos, clouds of gas and dust started to collapse under gravity's embrace. These protogalactic clouds grew over eons as they merged and gathered more material from their surroundings. The Milky Way likely began as smaller protogalaxies that merged and grew over time. These early unions set the stage for the galaxy we know today. A spiral beauty with a central bulge, graceful arms, and a halo filled with ancient stars and globular clusters. Stars in our Milky Way form within dense clouds of gas and dust. These clouds collapse under their own gravity, birthing clusters of stars. As these stars live out their lives, they enrich the galaxy with heavier elements through processes like supernova explosions. Like living organisms, galaxies evolve through interactions with their cosmic neighbors. Collisions, mergers, and gravitational dances with other galaxies can spark bursts of star formation or reshape a galaxy's appearance over billions of years. To understand these cosmic dramas, astronomers use a toolkit of telescopes and surveys. Optical telescopes capture visible light, revealing the colorful tapestry of stars and gas. Radio telescopes detect radio waves from hydrogen gas, mapping out its distribution. Infrared telescopes peer through cosmic dust to reveal stellar nurseries where new stars are born. Looking ahead, our Milky Way is heading for a cosmic rendezvous with the Andromeda Galaxy in about 4 to 5 billion years. This galactic tango will eventually lead to the birth of a larger elliptical galaxy, reshaping the destinies of both galaxies and their stellar populations. Studying the Milky Way's formation offers insights into profound cosmological questions. It helps us understand how galaxies emerged and evolved within the vast expanse of an expanding universe and the intricate cosmic web of structure formation. And how scientists explore galaxy formation. 1. Scientists use telescopes and observatories to peer into the depths of space. Optical telescopes capture the light from stars and galaxies, providing vivid images and spectra that reveal their properties and compositions. Radio telescopes detect signals from hydrogen gas, essential for mapping out the dynamics of galactic evolution. Infrared telescopes unveil hidden cosmic corners where new stars are born amidst dust and gas. Modeling galaxies involves computational astrophysicists simulating the complex dance of gravity, gas dynamics, and stellar evolution on supercomputers. These models predict how galaxies form and evolve under different conditions, including the influence of dark matter and the feedback from stars. Discovering cosmic secrets is achieved through spectroscopy and gravitational lensing. Spectroscopy analyzes the light emitted by stars to reveal their age, temperature, and chemical composition, providing clues to their formation history. Gravitational lensing bends light around massive objects like galaxies, helping us map out the elusive dark matter that shapes their structure. Future frontiers in astronomy include telescopes like the James Webb Space Telescope, which promise to unveil the earliest galaxies formed shortly after the Big Bang, pushing the boundaries of our understanding of cosmic origins. Advanced data analysis techniques, including machine learning, will help scientists sift through vast amounts of data to uncover new insights into the formation and evolution of galaxies. In conclusion, the study of galaxy formation is a journey that combines human curiosity, technological ingenuity, and scientific rigor. By peering into the depths of space and running simulations of cosmic events, scientists continue to unravel the story of how galaxies like our Milky Way came to be and what their future holds in the ever-changing cosmos. Okay, let's start our topic. The formation of Earth. The solar system. In the past few billion years, Earth has been pummeled by asteroids, crashed into other planets, and frozen over several times. Not to mention being ruled by all kinds of crazy life forms. Sometimes it's a wonder that our blue homeworld has survived at all. 4.5 billion years ago, some 4.5 billion years ago, Our solar system began to emerge out of a dense cloud of interstellar gas and dust. This cloud collapsed into a swirling disk of matter that got hotter and hotter and hotter until hydrogen fused into helium. And just like that, our sun was born, and baby Earth was on its way too. After the birth of our star, all the matter on the farthest ends of the spinning disk began to clump together. These clumps would be the seedlings for the planets and moons in our solar system. As they accumulated more matter, they grew bigger and more spherical. The clumps in the cooler regions of the solar system were mostly made of ice, liquids, and gases. Closer to the Sun, all the rocky material formed the inner planets like Mars and Earth. This young Earth was incredibly active, volcanically speaking. It spewed out gases like hydrogen sulfide, methane, and carbon dioxide. These gases made up the very first atmosphere on our planet. Early Earth was constantly bombarded by large asteroids and comets, and soon, Earth experienced an even more violent collision. Theia, a planet the size of Mars, slammed right into our young world. This epic collision threw chunks of matter all around Earth's orbit, and then gravity bound them together into what we now know as the Moon. 3.8 billion years ago, on this hot early Earth, there were no oceans. All water existed as gas. But 3.8 billion years ago, our planet cooled enough for water to condensate and become liquid. The very first primitive ocean covered this young Earth and turned it into a water world. H2O is an essential ingredient for creating living things. So, with all that water, life appeared on Earth about 3.7 billion years ago. These earliest forms of life were microscopic organisms, but it was nearly a billion years after that some of these organisms changed the course of the world. 3.3 billion years ago, Earth didn't stay as a water world very long. Soon, the very first continents emerged from the ancient ocean. Scientists call them cratons. As more and more land rose from the ocean, the very first supercontinent appeared on the planet. Valbara wasn't exactly a supercontinent. It was pretty small. Scientists think it was smaller than the continent of Australia. 2.4 billion years ago, around 2.4 billion years ago, cyanobacteria evolved to become our planet's first photosynthesizers. Finally, we had some oxygen producers to make Earth's atmosphere much more hospitable. And the rest is history, folks. Just kidding. We've still got a long way to go. With all this new oxygen, Earth's atmosphere had much lower levels of carbon dioxide, and that made the planet icy cold. Much of our young world froze over as Earth saw its first ice age. 1.1 billion years ago, now as Earth's atmosphere was changing, the continents were moving too. They broke up and reassembled into the next supercontinent, Rodinia. Rodinia was a real supercontinent. It may have been the largest supercontinent to ever cover the planet. And life? Well, life finally became more complex. But then something happened. Rodinia broke apart and a new supercontinent assembled. This one was called Pannotia. Then, Between about 540 and 485 million years ago, there was an explosion of new life. This time was called the Cambrian explosion. And the animals that evolved during this period had hard body parts like shells or spines. The most famous of all were the alien-looking trilobites. Around 440 million years ago, the climate suddenly shifted and the temperature of the ocean changed dramatically. Earth saw its first mass extinction event. This was the Ordovician-Silurian extinction, and a majority of the life that had been spreading around the planet vanished. Somewhere between 420 to 350 million years ago, the first trees arose from Earth's soil, and the first animals made their way to land too. 250 million years ago, the planet was covered by our last vast supercontinent, Pangaea. Sadly, it was also during this period that Earth witnessed the greatest mass extinction event in our history. The Great Dying. Huge amounts of greenhouse gases and accelerated global warming wiped out about 90% of all species on Earth. But this mass extinction helped pave the way for the next wave of animals to evolve. 240 to 230 million years ago, the first dinosaurs appeared. For the next 150 million years, they'd rule the land. If you were there, you'd have witnessed the gigantic sauropod Argentinosaurus, the largest land animal ever. Or you might have been chased by one of Earth's greatest apex predators, the T-Rex. And you'd also witness Pangaea breaking up and forming the continents we know today. 66 million years ago, an asteroid slammed into our planet right where Mexico sits now. And it coughed so much debris into the atmosphere that it blocked out the sun. This led to devastating climate changes that caused the dinosaurs to die out. In the next wave of emerging animals, mammals became more common. 6 million years ago, around, the earliest known humans started walking this world. This species was called Sahelanthropus, though they likely still walked on all fours. 4 million years ago, early humans began to walk upright. And about 1 million years later, they developed the first known tools, which they used to break things. Some 800,000 years ago, things sparked. These early humans discovered how to control fire and could now cook food and provide themselves with heat. Their brains continued to evolve, now more rapidly than ever. These humans learned to interact with each other and the surrounding world in whole new ways. Jumping way forward to about 250 years ago, the Industrial Revolution took place. We went through major technological, socio-economic, and cultural transformations. Rural, farm-based societies became more industrialized, urban ones. Our human population continued to grow. And now there's a new threat to human existence and many other forms of life here on Earth. Climate change. Temperatures and sea levels are rising worldwide, and biodiversity is declining. We could be on the verge of another mass extinction event if things don't change. So that's all for this video, and make sure to subscribe to my YouTube channel, Aerotech Afros the Programmer, and like this video. So let's meet in another video. Before ending this video, I want to explain how I gathered this information. I was reading a book named Space and Astronomy. If you want, the buying link is in the description.